In this video, we want to talk about kind of some polar review and thinking about finding some things out about the graph and also talking a little bit of area. So first of all, I say let r equal 5 minus 2 sine theta, and I'm going to find where the curve has horizontal and vertical tangents. Now, horizontal tangents, remember, are always where the derivative is equal to 0. Vertical tangents are where the derivative is undefined. Now, this is one of those situations, if you can remember from when we first started talking about polars, where we're going to have a little bit of work to do, and we're going to actually find dy d theta, the derivative of y with respect to theta, and the derivative of x with respect to theta, and we're going to make that a fraction. So when we say we want dy dx to be 0, what we're really saying is that we want dy d theta to be 0. And when we say we want dy dx to be undefined, what we're really saying is we want dx d theta to be 0. Okay, because dx d theta would be the denominator, dy d theta would be the numerator. But another way to think about it is y tells us if we're moving up or down. Well, if dy d theta was 0, that means we're not moving up and down, and therefore are only moving horizontally. If dx d theta, x tells us side to side, so if that's 0, that means we're only moving up and down, and thus would be vertical. So a couple ways to think about it. Now, we got to remember that y is equal to r sine theta, and x is equal to r cosine theta, meaning that for us, r is 5 minus 2 sine theta, and we've got that sine theta at the end. So there's our r sine theta, and then cosine would be r, or x would be r cosine theta. So as we go to find the derivative, remember we're doing dy d theta divided by dx d theta. So we've got first times derivative of the second plus second times derivative of the first. Now remember, to be a horizontal tangent, all we're concerned about is making that numerator 0. But I'll find the denominator at the same time. First times derivative of the second plus second times derivative of the first. Now, here's what I did. I actually graphed just dy d theta, and I did it in my y equals, and every time I saw theta I just made it x, but here's what I got. Okay, this is dy d theta. Okay, this is just me graphing the numerator. So you can see what makes it 0 are pi over 2 and 3 pi over 2. So let me just go up here. Where dy d theta is 0 is pi over 2 and 3 pi over 2. Those are the thetas. Okay. So then I graphed dx d theta. Here that is. There's dx d theta. And not quite as clean an answers maybe, but you can see what makes that 0 is 3.466 and 5.959. Okay, so again, I just isolated them basically. I said, you know what, I want to know when dy d theta is 0, so I graphed just dy d theta, and I saw what its zeros were. Easiest way to graph it is in your just y equals. Don't try and graph this in polar. And then I said, well, to find vertical, I want to know when dx d theta is 0. So I graphed that just by itself. And what I wanted to show you here at the end is just how this did work out. So if I plot those And I may have to shrink them down as I go here, but I graphed those on my calculator, and you can see that when I asked for the value at 5.959, I got the spot where there's a vertical. When I asked it to give me the spot where theta was pi over 2, I got a horizontal. When I asked for 3 pi over 2, I got the horizontal. And let me just pull up this last one. When I asked 3.466, I got the vertical. So it does work. It's a lot of work, but it does work out pretty nicely to do it that way. Now I also want to find the area inside this curve. If you'll remember, area in polar is always 1/2 the integral of r squared d theta. Okay. The r squared comes from we're doing this with a triangle, 1/2 base times height, where as the triangles get narrower and narrower, the base and height approach each other. So for us, we're going to have 1/2 the integral of 5 minus 2 sine theta squared d theta. And we just have to then find the bounds that enclose this. If I plug in 0, if I plug in 0 to r equals, I get 5. So this is the starting spot, the initial point. And if I plug in, like, let's say pi, I would get a 5 out this way. So this is where theta is pi. So 2 pi would bring me back to where I start. So the bounds are 0 to 2 pi. Never a bad idea to just plug in some points, and see exactly where on the graph you are. But you type that in your calculator, and that would give you the area.